And then we have just one last topic here on this page, which is called the squeeze theorem. And the squeeze theorem basically states that if you have a function g and you're trying to find the limit of the function g and you don't know how to do it, you can't use algebra, you're kind of stuck. Well, if g is between a function greater than or equal to f, less than or equal to h, and you know what the limit of f and h are near some value a, okay? Doesn't matter what happens at a because g of a could be undefined, like there could be a hole there, an asymptote, don't worry about that, just needs to be near a. Basically, if these two limits, the limit of f and the limit of h, are the same and they equal L as our limit, so the limit below g is L and the limit above g is L, that means we've squeezed our limit to be L. And let me show you how this works. So we don't know what the limit of x squared cosine of 1 over x squared is. But I do know that cosine of 1 over x squared has to be less than or equal to 1 and greater than or equal to negative 1 because I know that the range of a cosine function is from negative 1 to 1. And then I can multiply all three parts of this inequality by x squared. And the x squared, by the way, is coming from this component right here. So that means I have negative 1 times x squared, or negative x squared, less than or equal to x squared cosine of 1 over x squared, less than or equal to x squared. And we were trying to find the limit as x approaches 0 here. So if I do direct substitution and plugged in 0, I get out that the limit on the left is 0. And if I do direct substitution here and plug in 0, I get the limit on the right is 0, which means that this overall limit is squeezed between 0 and 0, and therefore the limit is equal to 0. Next question, we could do the exact same way, except for the fact that I don't have a guaranteed range of my e to the sine of 1 over x, so that is a problem. So what I'm going to do is the following. I'm going to use the fact that I know that sine of 1 over x does have a restricted range. So sine of 1 over x has to be less than or equal to 1, greater than or equal to negative 1. And then, since I really needed e to the sine of 1 over x, I'm going to exponentiate with a base of e on all three sides of the equation. So e to the negative 1 is actually 1 over e, and then I have e to the sine of 1 over x in the middle, and I have just e on the right. Well, now I'm going to have to multiply by that x squared. So I have x squared over e is less than or equal to x squared e to the sine of 1 over x, which is what we're trying to find the limit of, is less than or equal to e times x squared. Now, if I go ahead and plug in by direct substitution 0 into x squared over e, I know that my limit is 0. Same thing on the right, if I plug in by direct substitution x equals 0, I know that this limit is 0. So my overall limit is once again going to be 0 because we're squeezed between the limit of the lesser function of 0 and the limit of the upper function as 0. That wraps the core lesson. What you have left to do now is a set of practice problems in another presentation.